So in this series of videos on complex numbers, we're kind of taking a break and reviewing information that you probably already know about complex numbers before we progress on into some other topics we're going to finish the semester with. So let me start by just reminding you, when we talk about a complex number, the definition of a complex number would be if I was going to take the square root of -1, that would be I, which is an imaginary number, or I squared is equal to -1, because I could take the square root of both sides. So if I have an imaginary number here, which is represented by I, and it's talking about a negative under the radical, or the square root, then a complex number would be defined as its real portion and the imaginary portion. So the real portion are the numbers that you would normally associate with things that you've done that you're familiar with. 1, 3, -1, fractions, decimals, all of those kinds of things are real numbers. And then we have our imaginary numbers, which have to take into account, or which are really about taking the square root of negative, or the square root of negative values. So a complex number is the combination of real and imaginary parts. And just as a reminder, when I take the square root of, let's say, -a, what you're going to think is, first of all, I'm taking the square root of a -1, which comes out as just I, and leaves me with the square root of my letter A. We're going to practice those in just a second. So in this first example, we just want to practice writing a number as the product of a real number and letter I. So if I was looking at the square root of -25, when you first write these, let's take care of the negative portion, which comes out as just I, and now it's the square root of the number 25. I can take the square root of 25, and I know that that's just 5. So we write that as 5i. So let's try that again over here. The square root of, or the negative of the square root of -18. So if we take care of the negative portion under the radical first, we get -I times the square root of 18. Now to simplify the square root of 18, you want to ask yourself, what are perfect square factors of 18? Perfect square factors meaning 9 is a perfect square, and it is a factor of 18 because 9 times 2 equals 18. So I can take the square root of 9 and I would get 3. And then that just leaves me with the square root of 2. So my answer for this portion is -3i times the square root of 2. Now let's talk about performing an operation or simplifying something that looks like this, and then leaving our answer in what we would call the standard form. Now the standard form is going to be the real portion plus the imaginary portion, so it looks like this. So if we were to simplify letter A right here, what I have is -6 minus the square root of -24. So the numerator would just be -6 minus, now we're going to take an I out and we're left with the square root of 24, and then we of course have the denominator of 2. So to simplify the square root of 24, again you're thinking perfect square factors of 24. That would be a 4 and 6. So we can rewrite this as -6 minus 2i times the square root of 6 divided by 2. Now to check that you have simplified this correctly, we can square my number on the outside, so 2 squared is 4, times what's under the radical, which is 6, gives me back what I started with, so I know I simplified that correctly. Now, I want to simplify this and write it in its standard form, which means I've got a real portion and an imaginary portion. So we're just going to separate this out into the two fractions that it could be. So I can rewrite this as -6 halves minus 2i times the square root of 6 over 2. And I can see then that that fraction here at the leading fraction is just going to simplify to be -3, and then here we have minus I times the square root of 6. So I have my real and my imaginary portion combined to give me the standard form of my complex number. So we're going to try that again over here and see if we can come up with the same answer. So I want you to try this one. It's a little more complicated, but try this and we'll come back together and compare our answers. Okay, so if we were to simplify this and write it in its standard form, we would first simplify the imaginary or the negative square root here to be 5i times the square root of 2. And I still had the negative 5 in front, all over the denominator of 10. So if I separated this out into the two separate numerators, or the two separate fractions here, you can see that I can simplify both. The first fraction simplifies to negative 1/2. The second fraction is going to simplify to just the square root of 2 over 2. Now we pull the I in the front if we're writing it in this standard form, where you can clearly see that this number right here is an imaginary number, but I can identify that it is the square root of 2 over 2. So I went back and I wanted to re-emphasize that on the previous example, that although lots of times we see it written like this, negative 3 minus I times the square root of 6, and that is good. Most of the time we stop there. We can go one step further and rewrite it so that we have negative 3 minus the square root of 6i, if we wanted to really emphasize which portions are the real and which portions are the imaginary parts. Either one of these, I believe, would be acceptable in most cases. Course Compass or My Math Lab, where you're going to be entering this information, may be a little bit more picky with its answers because they are both equivalent solutions. Now these last two examples deal with how to solve a quadratic equation and give your answers which are non-real in their complex solutions. So give your answer as a complex solution. So if we're looking at this first example here, I have x squared plus 48. The way to solve that, there's two ways to do it, but I think I'm going to just subtract 48 to the other side, leaving me with negative 48 on the right and x squared on the left. Now to solve for just x squared, we would then take the square root of both sides. Remember though, when I take the square root of a negative number, I end up with a positive and a negative. I have, let's see, if I were to take the square root of 48, so I'm thinking of perfect square factors for 48, and that would be 16 times 3. So I have the square root of 16 is 4, so I would have 4i times 3. Now to recap, let me just make sure that I can get back to 48. So if I know I take 4 squared, which is 16, times 3, that's 48. So I simplified the radical, correct? I pulled the I out because of the negative under there, and since I'm taking a square root, I have to allow for both the positive and negative solutions. So that's how we would do that. The last one I'm going to let you try on your own because you've really been doing this. You should have been doing this and it should have been familiar to you to see this. We're going to use the quadratic formula to be able to solve this complex solution here. So I want you to pause the video, see if you can solve this by yourself, and then again let's check our solutions. So hopefully you remember the quadratic formula, but in order to get that, I first needed to bring the 2 all over so that everything is on the same side. So I added 2 to the left-hand side over here, and from here I'm going to use the quadratic formula. Remember the quadratic formula says negative b plus or minus the square root of b squared minus 4ac divided by 2a. And I just filled in all of the a's, b's, and c's. When I simplified this down, I got negative 7 underneath the radical, so I had negative 3 plus or minus the square root of negative 7 over 4. To simplify that, I just broke it up into its real and imaginary parts. So the first fraction is negative 3/4 plus or minus the square root of 7/4 I. And I just pulled the I out front so that it was clear that we had real and imaginary parts. And that's just some of the early operations or the simplifying of our complex numbers.